very good morning to our lecturers and fellow friends. Today, for our presentation of Geology and Drilling Laboratory, we'll present our Lab 3 experiment, which is solid and liquid content and emulsion characteristic of drilling mud. For our group members, I'll be introducing you guys to my group members, which are Hafizul Hani, Muhammad Aiman, Muhammad Hazik, and myself, Nurul Hazika. The content of this presentation is introductions, the objectives, theory, apparatus, procedures, result, calculations, discussion, conclusion, and lastly, references. For introduction, part A of the experiment. I'll be introducing you guys to the electrical stability tester, or in short, ES. This first part of experiment uses the electrical stability equipment. It is done to distinguish the emulsion properties by the amount of voltage and current flow in recorded mud. A higher reading of the ES shows good mud emulsion properties. From our experiment, the water-based mud gives an average value at 3.23 volts. Meanwhile, for the oil-based mud, it is 168.33 volts. Introducing you guys to part B experiment, we are using the retort kit in this part B. The solid and liquid content of the sample, which is commonly used the water-based mud, is determined by using this retort kit. The retort kit, which uses the condensation, heating, and vaporization of the drilling sample in order to get the results. It is heated until all the liquid has been vaporized, so in the end, you will have the liquid and solid content at the end of the experiment. The liquid and solid content is important for effective control of the properties of the mud. This retort kit can also clarify the poor performance of the mud. It is suggested whether the mud can better be conditioned by the addition of water, or whether it is appropriate to treat with chemical cleaner or to eliminate the contaminant. For the objective of the experiment, by using the ES, for part A, emulsion test, it is to determine the electrical state of drilled mud samples. And as for part B, solid and liquid content, it uses the retort kit, and the objective of the experiment is to determine the and solid contents of each of the water-based mud. I'll be passing through.
Okay, thank you Zika for the introduction part. Moving to the theory of the experiment, first of all, I am Muhammad Aziz bin Mahdi from Group 2 Lab Geology and Drilling. For the theory, apparatus and procedure part, I will present this part. First of all, for the theory of the experiment, one of the key properties of oil-based mud is electrical stability. It shows the voltage of the current flowing through the mud. The electrical stability number represents the stability of the mud emulsion. As the value increases, the more stable the emulsion is. If the mud has a good emulsion, the result of the equipment will be high electrical stability figures. On the other hand, if the mud emulsion is poor, the result will be a low electrical stability value. The conditions that affect electrical stability are such as form of emulsify use, continuous phase resistivity, suspended solid properties, non-continuous phase conductivity, temperature, droplet size, and dielectric properties of the shear background and the sample fluid. For the reading, the reading should be done with several readings because to prevent the outcome from being affected by the condition that was stated earlier, and to create a pattern that experiment required. Okay. Contaminant awareness is an important consideration for any drilling fluid for its use in real field conditions. Generally, the composition of the drilling fluid is containing oil, water, and solids. For the experiment B, the mud was initially heated in the retort kit at a high temperature. As the fluid boils, heat energy is obtained, and due to kinematic energy, it will collide with each other. As a consequence, the oil and water fluid in the mud shift from the fluid to gas. The collision that happens and breaks away from the solid part of the fork and looks for places where pressure is released and energy is gained. When the total quantity of the displaced water was 100 ml, the weight of mud is more than the weight of the dried mud. And the result will be explained later from Ayman. Okay, moving to the apparatus part. The apparatus part that was used in part A for emulsion test. The equipment used is electrical stability tester, a 100 ml beaker, and a calibration kit. For the material used is oil-based mud and water-based mud. The apparatus that was used in part B is solid and liquid content is the equipment is retort kit, measuring cylinder, and the material such as wetting agent, water-based mud, steel wool, grease, and cleaning agent. Okay, next we will move to the procedure part. Okay, before we starting the experiment, general startup procedure must be carried out. Okay, for the part A emulsion test, first of all, the calibration kit was placed in the socket and the test button was pressed until the reading remained constant. After the reading remained constant, the electrode body and the electrode cap were cleaned thoroughly with a towel. Okay, next is stability testing probe was inserted in the probe socket. The sample was collected in a beaker, and the sample will cover with electrode surface when immersing. The next is the sample was stirred thoroughly with the probe for at least 10 seconds. In the step 7, the on button was pushed to turn the instrument electronics on. And next step is test button was pushed and released to start the automatic voltage amp. And lastly, the reading was recorded. Okay, the step 5 until 9 will repeat 3 times to obtain average reading. The sample that used in this emulsion test are water-based mud and oil-based mud. Okay, for the part B, solid and liquid content experiment, the procedure we will start with retort kit was turned on and the upper chamber was stuffed with steel wool. And then sample was placed in the chamber and covered with its lid. The excess sample was allowed to escape and the excess was wiped with tissue. The sample chamber was secured with lid into upper chamber and tightened using the square brush retort wedge. Retort assembly was placed in heating compartment and insulating cover was put in place. Okay, for the next step is 3 drops of wetting agent was dropped into the measuring cylinder and placed under the dry part of condenser. The heater was turned on, and next the retort was let to heat until the pilot lamp goes out. The volume of the liquid in the measuring cylinder was recorded, and lastly the solid part of the sample was weighed after it has cooled. And last but not least, sample used in the solid and liquid content test was only water-based mud. Okay, that's only from my part. Next session I will pass to Aiman. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Aiman Zuhair bin Abdul Qadir. I'm from EH243 CCA. I'm from Group 2 for the lab Geology and Drilling. So today I would like to present a little bit for Lab 3. So this is given for our lab video presentation. So which is solid and liquid content. So let me share screen first. So which is as I mentioned before, lab 3, which is solid and liquid content and immersion. So for this lab, we performed it on 22 December 2020 last year. So for group EH243CA. So for the first part, 7.0 results. So for the part A, we got two parts, which is emulsion test and solid and liquid content, which is our objective to conduct this lab. So firstly, electrical data stability method. In a table, we classify it to two content, which is type of mud and resistivity of mud, which is V. So we only got two type basically, which is water-based mud and oil-based mud, WBM and OBM. So for the resistivity of method, this given data value by lab data for group 2. So first reading 3 and second reading 3.3 and third reading is 3.4. So for the oil-based mud, 170, 165 and 170. So basically we just calculate the average reading. So for the part B is given value, say weight of empty half mud 820 gram, weight of half is mud at 57.2 gram, weight of dry mud 9.4 gram, and weight of mud 37.2 gram. So for 8.0 calculation, the first one is electrical stability, which is we calculate the average resistivity V of the WBM. We just simply calculated, this is direct calculation, and we got 3.23 V, and for the OBM we got 168.33. So I put it in the table for the average reading. So for the solid and liquid content, which is its formula, weight of mud in gram equals to weight of half with mud, halves with mud minus weight of empty halves. So 857.2 minus 820.2 gram, which is we got 37.2 gram. So this is basically a direct calculation. For a deeper understanding, Madam or Miss should refer to our lab report. So it's basically a simple and direct calculation, and that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hafizul Hanif Beroslan, and I will continue the presentation for our group on the discussion of our science experiment. So the discussion is okay. First, it involves part A, the emotion test. So based on the calculation done previously and shown by my team group member, Muhammad Aiman. So based on the calculation, the average of resistivity of water basement is 3.23, and the oil basement has a average resistivity of 168.33. So this shows that the oil basement has better emulsion stability compared to the water basement. The higher reading of the electric stability, so it translates to a stronger and a more stable emulsion. This is because the higher the stability, the more the voltage is needed to break the emulsion. So the higher the resistivity will be recorded. Then a higher electrostability is also important because it will it means that higher electrostability means that it will give a smoother and shiny mud which will not adhere to, in this case, a mixer spindle. So meaning that if it used in the drilling process, the mud itself will not stick to the surfaces, the different surfaces in the drill bit even. So it will not form a clog, say, uh, in the uh, in the reservoir, or it cannot provide much resistance, so the flow will be smooth. The circulation will be much smoother in the reservoir during the drilling process, which is important because we want to ensure high penetration rate. Okay, so from that, we can discuss that the oil basement is better in terms of uh, electrostability, which means it is better emulsion, stronger emulsion than water basement. So, here is the YouTube video that I personally use as reference to I use as a reference, sorry, for the discussion based on the electrostability test in the first part of the experiment. So yeah, highlighted the stronger the emulsion, the higher the voltage required to break down the emulsion, completing the electrical circuit to conduct electricity. So higher the reading from the ES test, the higher, the greater or the stronger the emulsion is, the more stable it is. So discussion, the second part, which is the solid and liquid content. So for this, we use the retort kit equipment. So the amount of water displaced is 100 milliliter. The weight of the liquid content is the weight of the mud. Sorry, the mud with the liquid content is 37.2 grams, while the dried mud is at 9.4 grams. So if we subtract the both of them, we will get 37.8 grams, which will mean that the liquid content in the mud is 27.8 grams. So for this part of the experiment, we use the water-based mud because water-based mud is more frequently used than oil-based mud because it is cheaper, of course. And because oil-based mud will contaminate the cutting sample and the freshwater aquifer that might exist along the path, the drilling path. However, oil-based mud is used when well condition call for reliable shear inhibition or excellent lubricity. Okay, next is the conclusion. So for the conclusion, we have obtained both the objectives that we sought to do in our experiment, which is the first one. First part of the experiment is to determine the electrostability of the mud samples, and for the second part, to determine the contents of liquid and solid in the drilling fluid sample. So for the first part of the experiment, we can conclude that the oil-based mud is much more stable because of the higher electrical stability reading compared to the water-based mud. And for the second part, the conclusion is that the liquid content, of course, the oil and the water is at 27.8 grams, and the mud or the solid content is at 9.4 grams. So, and also the second part uses the water-based mud as the medium. So next is our references. So this is the journal and book references. As you can see, we have 3 journals or books that we use: Fundamental of Sustainable Drilling Engineering, Standard Handbook of Petroleum and Natural Gas Engineering, and also a journal, Electrical Stability, Motion Stability, and the Wettability of Invert Oil Basements. Then we have the reference from the internet. Of course, I have 6 websites that we base our reference from, and then of course a video like I shown in the discussion part, which is from Muhammad Ashora, how to measure electrical stability using electrical stability meter, basic math school. And that's all from me, and I believe that concludes our presentation, our video presentation for this experiment.
Thank you.
Thank you.